Dear viewers, I am N. Muzaffar Kani, Assistant Professor of Chemistry, Jamal Muhammad College. I would like to share the concepts of organometallic compounds, particularly metal carbonyls. What is called organometallic compound? The organometallic compounds denotes generally the compounds in which the organic compounds or organic groups are directly linked to metal atom through at least one carbon atom. The organic compound directly bind with a metal atom. For example, alkyl magnesium bromide. This is an example of organometallic compound. This is called Grignard reagent. On the basis of metal carbon bond, the organometallic compounds are classified into ionic bonded organometallic compounds, covalent bonded organometallic compounds. Ionic bonded organometallic compounds means that organometallic compounds of alkaline earth metals, lanthanides, actinides are more predominantly form ionic bonds. These all are more reactive, non-volatile solids. They are insoluble in organic solvents. For example, calcium cyclopentadienyl compound is an example of ionic bonded organometallic compound. Next one, covalent bonded organometallic compounds are classified into two different types. One is a sigma bonded organometallic compound, another one is a pi bonded organometallic compounds. The pi bonded organometallic compounds, for example, alkene, alkyne and some other type of organic compound have pi electrons, that pi electrons overlap with a metal atom. For example, metallocene. These all are examples of pi bonded organometallic compounds. Metallocenes, it consists with the pi electrons, pi orbitals. Z is a salt also, the pi orbitals coordinate with the metal atom. Now we want to know sigma bonded organometallic compounds. For example, metal carbonyls. The organic compound, that means carbonyl compound, coordinate with the metal atom through sigma bond. So this metal carbonyl derived from sigma bonded organometallic compound. Now we want to know the elaborate part of metal carbonyls. Metallic carbonyls. The carbon can donate its pair of electron to metal atom or forming metal carbonyl coordinate bond. The compounds are formed by the combination of carbonyl molecule with metal atom are known as metal carbonyls. The metal carbonyls, in metal carbonyls, metal present as a zero oxidation state. The carbonyl act as a neutral ligand. For example, nickel tetracarbonyl. So these type of metal present as a metal carbonyl, all the metals are zero oxidation state. Now we want to know the classification of metal carbonyls. Metal carbonyls classified based on type of ligands and based on metal centers. Based on type of ligands are classified into two different parts. One is a homoleptic metal carbonyls and another one is a heteroleptic metal carbonyls. In homoleptic metal carbonyls, only one type of ligand is present. The general formula of this metal carbonyl, these all are examples of homoleptic metal carbonyls. The next one, heteroleptic metal carbonyls. In heteroleptic metal carbonyls, more than one number of ligands are present. The general formula of this heteroleptic metal carbonyl is, this is an example of heteroleptic metal carbonyls. You know that, just watch this one. Based on type of ligands, the metal carbonyls are classified into two different types. One is a homoleptic metal carbonyls, another one is a heteroleptic metal carbonyls. In homoleptic metal carbonyls, only one type of ligand is present in homoleptic metal carbonyls. General formula of homoleptic metal carbonyl is MxCOY. For example, nickel tetracarbonyl, iron pentacarbonyl, chromium hexacarbonyl. The next one, heteroleptic metal carbonyls. In heteroleptic metal carbonyls, more than one type of ligands are present. The general formula of the heteroleptic metal carbonyl MxLmCOY. For example, PtCl2 carbonyl, two carbonyl ligands associate with a platinum metal atom. This is an example of heteroleptic metal carbonyls. Furthermore, the metal carbonyls are classified based on metal centers. Metal carbonyls are classified mononuclear metal carbonyls, polynuclear metal carbonyls. In mononuclear metal carbonyls, only one type of metal atom present in this complex. For example, nickel tetracarbonyl, iron pentacarbonyl and chromium hexacarbonyl. These all are examples of mononuclear metal carbonyls. Polynuclear metal carbonyls have two or more than metal atom present in this complex. These all are examples of polynuclear metal carbonyls. Polynuclear metal carbonyls have two or more metal atom present. For example, dimanganese decacarbonyl, dicobalt octacarbonyl, then manganese cobalt Na-carbonyl. These polynuclear metal carbonyls classified into two different parts: homonuclear metal carbonyls, heteronuclear metal carbonyls. What is called homonuclear metal carbonyls? The homonuclear metal carbonyls have metal atom present as a same type. Heteronuclear metal carbonyls have the metal atoms present as a different type. For example, it is an example of homonuclear metal carbonyl. It is an example of heteronuclear metal carbonyl. Now we have discussed what is called organometallic compound, how can be classified, then what are the metal carbonyls, how are they classified. Then only we want to know the structure of mononuclear carbonyls. These all are familiar examples derived from mononuclear carbonyls. Now we want to know the structural aspect for nickel tetracarbonyl, iron pentacarbonyl and chromium hexacarbonyl. The nickel tetracarbonyl, the atomic number of nickel metal atom is at 28. Atomic number of iron metal atom is at 26. Atomic number of chromium is at 24. The outermost electronic configuration of nickel is a 3d8 4s2, for iron 3d6 4s2, for chromium 3d5 4s1. From this one, it is also found to be diamagnetic character. Nickel tetracarbonyl is a diamagnetic character, and the hybridization of nickel tetracarbonyl is a sp3. How is it possible? It may be derived from its structure. Is it? This is a structure of nickel tetracarbonyl. It is a tetrahedral geometry. How can be said about the diamagnetic character? sp3 hybridization based on its valence bond theory. The outermost electronic configuration of nickel atom in ground state 3d8 4s2. The 3d orbitals consist with 8 electrons, the 4s orbital consists with 2 electrons. Is it? The nickel atom in nickel tetracarbonyl present as a 3d10 4s0. The valence shell electron of the nickel atom is a 3d10 4s0 in nickel tetracarbonyl. All the orbital, that means 3d orbital filled up by the 3d10. The remaining 4 orbitals, the 4 carbonyls donating the electrons to this s orbital and p orbital, that's only this is a sp3 hybridization. The absence of unpaired electrons, nickel tetracarbonyl shows diamagnetic character. So that in that nickel tetracarbonyl is a tetrahedral geometry, diamagnetic character and the sp3 hybridization. The next one, iron pentacarbonyl. Iron pentacarbonyl looks like as a trigonal bipyramidal shape. So here this iron pentacarbonyl provide the information about its structure, trigonal bipyramidal shape. The iron and carbon bond length is a 1.84 Armstrong. It is determined by X-ray diffraction study, and it is a dsp3 hybridization, and the absence of unpaired electrons, iron pentacarbonyl shows diamagnetic character. Outermost electronic configuration of iron is a 3d6 4s2. The 3d orbital consists with the 6 electrons, the 4s orbital consists with the 2 electrons. The valence shell electrons of iron in iron pentacarbonyl present as a 3d8 4s0. So here this d orbital consists with the 8 electrons. Remaining vacant orbitals filled up by the carbonyl. The carbonyls tends to donate electrons to metal atom. The 5 carbonyls donate electrons to metal atom, that's only it is a dsp3 hybridization. Absence of unpaired electrons, iron pentacarbonyl shows diamagnetic character. These all are the informations of the structure of iron pentacarbonyl. The next one is a chromium hexacarbonyl. It is also mononuclear carbonyl. Now, the chromium surrounded by 6 carbonyls. These 6 carbonyls tends to donate the electrons to this chromium metal atom. The next one, outermost electronic configuration of chromium is a 3d5 4s1. The 3d orbitals consist with the 5 electrons. Then 4s orbital consists with the 1 electron. The chromium present in chromium hexacarbonyl has a 3d6 4s0. This orbital consists with the 6 electrons. The remaining orbitals filled up by the carbonyl groups. The carbonyl groups tends to donate electrons to the remaining orbitals. That's only D2sp3 hybridization for chromium hexacarbonyl. Absence of unpaired electrons shows chromium hexacarbonyl is a diamagnetic character. So that we want to comprise this one. Chromium hexacarbonyl is octahedral geometry. The chromium carbon bond length is a 1.16 Armstrong. It is a D2sp3 hybridization and it is a diamagnetic character. Then until now we have discussed what are organometallic compounds, how are they classified, what are metal carbonyls, how are they classified. Then only we have discussed the structural study of mononuclear carbonyls. In next video we want to discuss 18 electron rule applied to metal carbonyls and effective atomic number rule applied to metal carbonyls. Thank you for watching. Comments are most welcome. Thank you.